So this brings me to the last contribution to this session, which serves to highlight a remarkable collaboration between an industry partner and a team of students. So please join me in welcoming on stage Audrey Ventura from the Student Association Swiss Solar Boat and Dr. Gerritt Schatte from the Kistler Innovation Lab, please. So Kistler has recently joined the K-Nova program to start exploring the EPFL ecosystem from the ground up and have since launched a number of collaborations, one of which is with Swiss Solar Boat. And so, Gerritt, Audrey, we're excited to hear more about it.
Thank you very much, Holger. Thanks. So we'll briefly share with you in a trilogy the story of what this collaboration is about, how it came to be, and why it is beneficial for both the EPFL and for Kistler as a company. So starting off with the first chapter is how this collaboration came to be in the first place and who Kistler is as a company. I want to keep this part very brief. We are the world market leader in dynamic measuring technologies for a range of R&D and production applications and other niche applications, and innovation is at the core of our DNA. And we had the desire to interact with EPFL to seize more innovation opportunities than we can do in-house. And for this, we joined EPFL's open innovation platform called K-Nova, which is a program which really takes companies that have this general wish to innovate more and with externals takes you in, brings you closer to the EPFL ecosystem, you become a managed account, and it becomes very, very easy for you to satisfy your specific innovation and research needs together with EPFL. And to highlight that a little bit compared to the closed innovation model, if you have to develop everything in-house, you open up your innovation idea funnel and realize certain opportunities that you cannot realize in-house with other stakeholders. And in this case, the collaboration with the Swiss Solar Boat is an example, and Audrey will share some more information about the Swiss Solar Boat.
So, hi, my name is Audrey Ventura. I'm here a student at EPFL doing my master's in mechanical engineering. I'm also head of the structure division at Swiss Solar Boat. So Swiss Solar Boat is a team of around 60 to 70 students coming from a variety of engineering backgrounds. So the association was created in 2019, and the first boat that you can see on the screen was finished in 2021. So we participated twice in the Monaco Energy Boat Challenge and ended up with great results. But now the team is going towards a new challenge. So building a new boat propelled with solar energy as well as hydrogen. So one of our current challenges is also to have a more sustainable production process. So we have to choose the right materials. But to do that, we have to analyze how our structures behave under stress and strain. So now we are doing it by simulations on softwares, but the ultimate goal would be to have real measurements of deflection, for example, on the hull of the boat or on hydrofoils. So it is on this topic that our collaboration with Kistler took place, and I will let Gerritt talk about our project.
Thank you very much. So obviously this is a very good match, and our partners from the K-Nova program mentioned to us, hey, maybe you should talk to those guys from Swiss Solar Boat, maybe there is a chance. And in fact, we were able to bring together this particular challenge together with a newly developed sensor from our side, a so-called shape sensor, which enables us to measure the shape of surfaces in real time with high resolution. And the big advantage here for us is we are actually not composite fiber people, we are sensor people, but we need to know about the application to deliver the perfect sensor to potential customers. And so solving both of our problems in a collaboration was a no-brainer for us. And in this case, we did, in the last few months, initial tests applying the sensor to some test specimens in the lab, and the results are very promising. So we are very happy about this. So overall, this collaboration project, for us, the benefit is to learn the specifics of a new application, to get the understanding of the user technology interaction and access, of course, the know-how at the laboratories, the passion from the students working on this particular project, and to be able to really work in an explorative way, which we could not do in-house as easily as that. Maybe. And to you.
Yeah, so for the Swiss Solar Boat team and the Make associations in general at EPFL, one of the benefits is to first discover new technologies and to be able to apply them to our project, as well as using the knowledge that we get during our studies at EPFL. It is also good for us to be surrounded by professors and laboratories, such as Véronique Michaud from the Laboratory of Composite here at EPFL, and also experts in their engineering fields, like Kistler in this case. It is also very good for us to get more experience with the industry and to step foot in the professional world. It is also a way for us to get opportunities like internships or jobs.
Thanks, Gerritt. Thanks, Audrey. Take a seat. Maybe one or two quick questions. We'll start with Gerritt. Yeah, you say you needed to learn about the specifics of an application, but why in this particular collaboration project did you forego a more classical, collaboration with an EPFL lab and chose a student project instead? Where do you see the differences and advantages?
So the reason behind that is threefold. There are three main reasons. The first one is, of course, the expertise which is available at EPFL in this particular field, which we do not have in-house. The second is, of course, the time and the resources needed to perform such experiments completely in-house for us are just very large, and at EPFL these materials and the resources are available completely, and it's very easy for us to go into this environment. All of these tests happened within a matter of months, whereas if we would have to set it up completely internally, it would have taken half a year plus. And the third is to follow an explorative results together also with the student body and to be able to explore new ideas without there being huge, let's say, consequences in terms of system costs for us. Yeah. So.
Thanks, Gerritt. And for you, Audrey, in which way has this specific interaction, the integration of Kistler into your Swiss Solar Boat project, changed course and impacted the project?
Yes, so for us, the impact when having partnerships with industries or companies is always great. Because us, as students, we don't necessarily have the possibility to use or to have new technologies or new materials. So it's often very costly, and we cannot afford them. So the idea is for us to have partnerships, to have access to all these technologies, to new materials, and actually the EPFL gives us the infrastructures to do testing, and we also, as students, give a lot of time and develop a lot the projects and go very deep into them, but without the partnership with a company, we cannot get access to the technology.
Thanks, Audrey. Final word to Gerritt, perhaps, so you've made your experience here. So starting with K-Nova, very, very low friction entry into the EPFL ecosystem. Do you see that this will now serve to deepen your ties with EPFL?
Absolutely. I mean, this is not the only project we were able to kick off with EPFL through this program. So we have a joint lecture, we have some Kistler measuring materials which we sponsor at some labs, and we have ongoing research activities with other chairs as well, and we're looking forward for more to come. So absolutely happy and thrilled to be part of the system here.
Thanks. So once again, thanks to Audrey and Gerritt. Thanks to all the speakers of this session, and I hand the word over to Robert.